Right, we've finally got onto it, the trade Colt 295A. So we've covered this several times. The 295A has got high-low power. The 295 without the A has high-low RF gain because it was produced before the final MPT 1320 UK government rules were actually unleashed. So the dealer's already put the power connector on that, and we will go in there with a crocodile clip. I don't know whether he's given me any notes or whether I've just not read them. We'll soon find out what ails it, I'm sure. Right, there we go. As you know, we do manufacture the power connectors for these with the original, still currently made mouldings. We do stick those on eBay, and postage keeps going up. Last time it was 40 pence change in postage. They don't mess about. No, they don't mess about with the 5%. They just do massive increases. And what they don't realise is that the courier type companies will eventually be cheaper and offer all the tracking and services like that, which post office don't ordinary mail. So we've got a set there, the meter doesn't light, and let's see whether it works in PA. Is it this chassis where it's uncontrollable? No, it's this chassis that comes through the PA and the extension speaker socket simultaneously. I'll just plug the test instruments in as well, and while we're at it, we'll plug the test instrument in to the aerial socket. So I haven't started a sheet yet. As you can see, it's actually got the meter preset there, which some don't. Let's see if it works. Testing 1 2, testing 1 2. So PA comes out of both speakers just as we predicted. Interesting, no receive. Got transmit. I'll put picture in picture and then we can see whether we've got transmit if we were on the right camera. No transmit. Transmit light doesn't light, but then a lot of the time the transmit light doesn't light. So we better look initially at the 8-volt regulator, which is there. Can't remember whether the chassis is floating or not. Looks like its chassis is negative, so we should have rail voltage, which we have. We should have 8 volts, which we have. So that's a jolly good start. So which pin of the phase lock loop chip has power? Well, we've got nothing there, have we? We're going to have to start looking at the squirket diagram. So the fact we've got no transmit, we've got no receive hiss, we know the amplifier's working. Sure, we can prove that it's in on receive, hopefully. whichever pin's the input. There's just one thing I'm going to try before this sounds silly, just in case it's not quite in PA mode or not quite in radio mode. I'm going to switch the power supply off. We're just going to switch the PA mode about 20 times. Switch power supply back on. It was worth a try, wasn't it? Back to the circuit diagram. I'll pause the video while we find one. Okay, I thought we'd go for another little... Oh, well, I printed this off, which is supposed to be the 295 rather than the 295A. Yes, I think that's right, because it's got high-low RF gain by the looks of that. So it's not lying. Yeah, RF gain high-low. So this is nearly the same, but it's just not got the high-low power for the transmitter. I just thought there's a possibility, of course, that I'm using the standard mic, which is the Commtron wiring, and it's just possible that the mic is wired slightly differently. So I thought, I'll tell you what we'll do. We'll just see whether the radio is receiving, and hey presto, look, it is receiving. There's 100 microvolts. So I might have got something which is wired differently, and it may be that because my mic's wired differently, that I'm not getting any receive for a start, and of course no transmit. So to put it into receive, we should be looking at the circuit. We should be between pin 5 and pin 4. Pin 5 and pin 4. So I'll tell you what, here's a bit of solder. So remember, these, because they were hi-fi connectors, it started off as 3-pinned in. So it started off as, let's try and point with something. Pin 1, pin 2, pin 3. Pin 4, pin 5 are those inner ones, which will be the right-hand channel if it was stereo. So in fact, all we've got to do is to put a link between the two, what would be the two stereo content pins if it was a hi-fi. Will it receive? We had quite a spate of Commtrons coming in, so I didn't have a problem with those. In fact, it goes into transmit. Absolutely fine. So why should there be a difference? I can't understand that. So the radio does transmit, so it's generating frequency, so I don't need to start looking at voltage around the face like a loop. I might have to make another mic up for this. See if we can find another one on the bench that's got a DIN plug on the end. I've got an unknown one with a DIN plug up here. Ah, that's going to be realistic because it's a... Whoa! Pulls on a cable. In fact, some of those... I've noticed when I'm editing, some of these cables have got in the way. that's realistic anyway. No, I don't think the Commtron mic's going to work with it, so we will make one up specially for this. Okay, so making another mic up, it's not made any difference. So I'm not quite finished. I did not put the casing on the mic, but I did check that my new mic works in PA. But I'm still not barking up the wrong tree when I was thinking about the public address switch. I'm still not sure. Well, I wasn't sure. So I've put my multimeter across it in PA mode and buzzed it through on its two terminals, and then I switched it from PA to CB mode, and I can't get it to buzz through. So I then shorted two terminals at a time. I had receive when I shorted one terminal, and I had transmit when I had shorted the other with a screwdriver. So it is the public address switch. So we're going to put some service on that. I've just pinched it off Mr. Chippy's bench while he's not looking, and I'll turn the power off once again, and we'll go. And now I'll do it again. Have to use the applicator for this. There is a hole in the side of the control which hopefully goes into the works. You know, it feels better having done that. So we'll try again. Power back on, public address, testing 1 2. There we go. It's not normal volume though, is it? And we've got transmit. So while we've got strangled volume, let's try the original. Where have I put the Commtron mic? So we do still have an issue. Anyway, so that was the big thing, and we have had this once before on a set with this chassis. Probably a Maxcom 4E, which is probably the most popular, with the rotary switch to switch it to PA on the squelch. We'll just pop this together. So we're gonna made up another mic for no real reason. So at least we've got one in stock, haven't we? We'll put the little screw in there. And then I'll label it Colt 295. It's not the normal volume, but there's probably something else. Mind you, I mean, the set could be out of alignment, couldn't it? The VCO's never been messed with, and I don't expect for a moment it's got the parts to check the VCO properly, so there we go. Just plug the test instruments in again. PA, CB, PA, CB. So I really ought to get a sheet of paper now. Right. Can anyone see the pen? 26 Oct 23 Colt 295A from Sheffield. Serial number 0004867. So no TX or RX, PA OK. So switches with a star, PA switch dirty. PA functions working, lamp doesn't work. Good grief. So it's doing 5 watts on channel 20. Oh, it's got the normal volume, it's just not right. Detector's miles out. It's doing 4.9 watts on channel 1, and it's doing 4.9 watts on channel 40. So we're going to have to retune it. It doesn't have low power. And the tune-out transmit current, if we go back to channel 20, is 1.215. Quite good for that power. So it's no good it being like that. It's not designed to source that all day. So legality aside, because I'm not going to have them over 4 watts anyway, but legality aside, you've got no range difference in just thrashing the set. So we'll go through it. Are we on the right meter? We're on the right meter. So we want that to peak. And it looks pretty well balanced as it is. That to peak. That to peak. So far everything's spot on. Until I got to that one. It's lost its bottom coil there. So the golden screwdriver experts discovered if you take that out, the set does more power than they should be doing. Hope it's not super glued. Yeah, got it. So we're now at 4.9 watts. It's probably, as it's warmed up, it's probably got slightly worse. Now we've got an AM scrap set here, because all AM sets are scrap here. Does it have the same core? And the answer is yes. This scrap set came from our mystery benefactor Alan, so there'll be no fee to matey for this part, thereby passing on Alan's kind gift. So with this one we're going to drop the power to 4 watts. Not quite gone. Not going to detune the others. Channel 1, 4 watts on the dot. Channel 40, 4.1 watt. We can actually balance that. gone the wrong way. So I've got 4 watts there. No, we can't balance it. Now that's better. Four watts on channel 1. No. .05 on channel 40. 4.05 on channel 1. 4.05 on channel 20. That's how it is, folks. We had this difficulty with those World Sound PT40s. It was difficult to get them under 5 watts. Right, what's the current consumption now? 1.062. Deviation, for what it's worth on this test set. 1 to 1.5 I've got. I'll set the deviation on this test set, and then we'll look at it on the test set behind me. That's 2.2 to 2.5. So we can't always trust this deviation meter. Right, so we're now on the Quartz Lock 282 test set behind me. Have a look. Wow, that is too high. That's it. Turn that test set off. Save some electricity. And see what the Marconi test set says now. Wow, it says 1.7, so it's playing up today. So it was actually correct. Can't do the V so easily, so we're not going to frequency. .79094. So we'll just bring that up. I mean, it was well within spec, but we just brought it up while it's here. See what the RF meter reads, if we can actually read it. So it says 3. Now it says 4. Okay, so we'll move on to the receive. So we haven't done it before, so I'll tune the thing in. All we've done is brought it on frequency. That doesn't affect the way the receive responds. So just set that for 2779125. Put the cyanide meter on ready. There we go. So, what we got? So for 12 dB, if we go over to the cyanide meter, I did press the button but it didn't happen. We've got 1.75 microvolts, and we can hear it's lousy. For 10 dB, it's 1.65, and if it ever does 20, it does actually. It does at 7.1 microvolts. S meter, 100 microvolts on the radio. It's reading slightly generous but not much. It's 75 microvolts. Squelch, I want it to be 100 microvolts. Let's put this on the attenuator. So that's 3, 10, 30, 100, 300, never opens. And at threshold position, let's park this back at 0.3 of a microvolts, switch it to standby, set the squelch on the radio. It comes in as a lousy 8.5 microvolts, so unusable round scratchy corner. I do know a team radio that works like that when it's normal. Right, let's get on with that. Well, clearly the detector's out, so I'll put the signal generator on 100 microvolts. We'll go over to the oscilloscope and see what silly scopeness we can see. Detector coil. I did say it was miles out. It's been golden screwdrivered. There we go. Right, now we'll go to the front end and over to the cyanide meter. Better turn the squelch down. So about 4 dB, so we're not saturating the receiver. There she blows. Back it down again. That's spot on. That wasn't though. Let's just go back on this one. Because they're interactive. And the first one. That's right. That's right. See, they haven't time at the factory to go backwards and forwards and backwards and forwards. Meet the line, send it out. We haven't got the extra circuit on this one. Let's see what the cyanide reading is now. That's about 12, 0.7 microvolts. For 10 dB, 0.65. For 20 dB, 1.25. See where the squelch is now. Turn the squelch to full. So we'll put this up back on the attenuator so that you can see 3, 10, 30, 100. So I need it to come in at 100. Well, it doesn't, does it? Let's put it to 300. Okay. That's minimum sensitivity. So what is minimum? Right, let's have a look. It's actually 485. Not ideal, but it opens at just under plus 30. Now then, here's the important one. It's got to pass this test. To squelch the threshold on the radio, signal generator is parked at 0.3 of a microvolt. Take it out of standby. Now it came in for a moment, so we're in the right region. Wow, 0.55, that's lovely. So the detector was the biggie. All but one of the things were golden screwdrivered. Potentiometers are fine. Sockets are fine. That's now 100. Oh no, I've not set it yet, have I? So now we can back that down with the preset on the back of the meter to 100. Done. Lovely radio. Out of interest, I expect the TX light needs doing. Oh, blow me, it doesn't. But the meter bulb needs doing. Perhaps Mr. Chippy'd like to earn some money on that. Meter lamp out. Good. Perhaps I ought to email the customer, because he's a trade customer. He may want to do that himself and cut the cost. Otherwise I'd add £3 to his bill plus the cost of the bulb. And you do take some doing. See what he says. Yeah, so we'll draw this video to a close without the meter lamp. It's a chassis only. We don't have any cases for it. I'll also plug it into the extension speaker on the wall rather than the instrument speakers. Right. One niner Roger. There we go. Nobody to talk to. Oh no, it's not on 19. 19 a Roger. These small knobs are difficult to turn with something as tough as a BCD switch like that. So that's a really pleasing result and hasn't been costly in parts. So I'm sure Mr. Sheffield will be chuffed. We've got another one in from him, which will be no doubt our next set. I would like to get those business radios done though. Thanks for watching the Colt 295A from the trade.